Okay, hi grade 12s. This is our last little video lesson for our electrochemistry unit, and it's basically just a very small unit or a small topic where we're going to look at what makes it a spontaneous or a non-spontaneous redox reaction. Okay, so after we go through page 23 and just the very top of page 24, there are some textbook questions that you can work with on your own, or you can work with your lab partner or somebody else in the classroom if you happen to be in class, okay? And then that's it for unit number 2. You'll have lots of time to make some study notes and go through any follow-up questions from the sample multiple choice test, so you're all ready for some of the test, the problem set types of questions, okay? All right, so on the top right here, you can just have a look at the definitions that we have for batteries and electrochemical cells. Remember that the setup that I showed you in the lab, where you've got your porous cup sitting in another solution, so you've got your metal electrodes in the metal ion, the ion solutions with the nitrates, okay? You've set that up as an electrochemical cell, and you can see the difference in the whole overall cell potential based on the reduction potentials of the metals that you have and the ions that are available, okay? So now, can you figure out and can you predict if a reaction is going to occur or not spontaneously? Okay, so here's how you figure it out. You're going to calculate the E0 value for your cell. Okay, so under a certain set of conditions, we can predict that. You can calculate this using the standard reduction potential from the table in the textbook. Okay, and if you calculate the E0 value to be a positive value, okay, it would read something on the voltmeter, then we know that that's the reaction that will be spontaneous. It'll actually occur because you get a positive E0 value. Remember what I said, that when you're doing your calculations for this, actually put the positive if it's a positive value, put a negative for the negative value like you normally would, but then double check, right? Always make sure you've got that positive or negative. That will help you figure out this type of question. Is the reaction spontaneous or not? Which one will be the cathode? Which one will be the anode? Where does oxidation reduction take place? Okay. If you get a negative value for the E0, so let's say I say this is going to be the anode, this is going to be the cathode, and you do your calculation and come up with an E0 value that's negative, that means that the reaction is non-spontaneous. It's not likely to occur in that direction. Okay, so now what does that mean? Well, this is a question that you did a follow-up one from the little lab activity where I gave you question 2, A, B, and C. This was the answer right to 2C. So a reaction that is non-spontaneous, well, it simply requires the input of energy that would be greater than or equal to the negative voltage for that reaction to occur. Okay, so because these reactions are reversible with the input of energy, you could write it as something called an equilibrium reaction. Now, we spend an entire half of our course talking about something called an equilibrium. And if you've ever seen a symbol that looks like this instead of a reaction arrow that goes just in one direction, essentially this means it's a reversible reaction. It can go in the forward direction and it can go in the reverse direction, and that's what we call an equilibrium. So with regards to an electrochemical cell, basically it's showing that you can make it go in the forward direction or in the reverse direction, just depending on how you're looking at the cell. Is it going to go spontaneously that direction, or is it one where it's non-spontaneous and you need to apply the energy in order to make it go that way? Okay, so that's just all we're saying here. But to simplify this, we're just showing you in the direction, okay, of the forward direction, and it's only written there, but recognize the fact that the equilibrium symbol would be forward and reverse, and where you can show it either way, right? That would be the exact same thing. Okay, so let's look at the first example here. So using a standard half-cell reduction table, yep, we know where to find that, determine if a reaction is going to occur when you have a strip of copper metal and you put it into a solution of nitric acid. So here you need to recognize the fact that it's talking about a strip of metal copper, and it's putting it into a solution that is HNO3 aqueous. So there's our solution of nitric acid, and that means, right, that we've got our hydrogen ions there and our nitrate ions, and of course our nitrate ions are going to be on both sides of our ionic equation. They'll cancel each other out, and we've been used to doing this by now, haven't we? There is our net ionic equation. Okay, so based on this net ionic equation, let's write down the oxidation half reaction, the reduction half reaction, and then we're going to figure out if the E0 value of this reaction is a positive or negative value. And by that, we're going to be able to figure out, does the reaction spontaneously occur or not? Okay, so we're going to look at the reduction potential table in the textbook, okay, and we're going to figure out that here's our oxidation for copper. Here's our reduction of our hydrogen ions, because that's what the reaction tells us. We want to see if this reaction is going to occur if we put the copper in the nitric acid. In other words, we're saying, does the copper get oxidized and do the hydrogen ions get reduced, right? That's what that's saying. Okay, so does the oxidation and reduction occur? Do your net reaction. Okay, of course you need to make sure you've multiplied this all by 2, right? Because you want to balance your 2 electrons that were lost from the copper oxidation, reflect that with your 2 electrons gained, okay? And what do you end up with? You end up with an E0 value that is a negative number. Here's your conclusion. Since the E0 value is negative, the reaction will not occur spontaneously. That means that if you put a strip of copper into nitric acid, no reaction will take place. To make this reaction occur, let's say you wanted it to occur, well then you would need to apply how much? Can you quantify that? And that's what you did in the lab question, right? You quantified it by saying you would need at least 0.34 volts applied in order to make it go in the direction that is non-spontaneous. Okay, can we extend this to another type of example? You can, okay? So here's the extension. Will a strip of copper react with hydrochloric acid? What about sulfuric acid? What about phosphoric acid? Okay, explain based on the information that you have above. So can you see here, pause the video, you can think about this for a second. All right, and you know that no reaction is going to occur because all of the acids will be undergoing reduction, right? Hydrochloric acid has hydrogen ions. Sulfuric acid, right? H2SO4, hydrogen ions. Phosphoric acid, right? H3PO4, hydrogen ions, okay? So copper will always want to be oxidized, therefore a negative E0 value will result, and the reaction would be non-spontaneous. Okay, so here are the questions you're going to work on, 1 to 5 right here. On the top of page 24, it goes over just again what we call these types of cells. And so I want you to just do a little bit of reading and work up to here, and then we're completely done our electrochemistry unit. Okay, I'll list in the lesson outline a few textbook questions to tackle, and these ones also have the solution sets that I've posted. Okay, so do a little bit more work on electrochemical cells and the definition for an electrolytic cell there, and that's it for electrochemistry. So congrats on a good hard unit, and I look forward to our next unit, which is going to be a unit on heat, or in chemistry we call that enthalpy. Okay, have a great day. Let me know how it goes.